Hey everyone, welcome to MBF 3C, which is College Preparation Math. I'm going to be your teacher, Miss Singh. I'm going to be making these videos so that you can go back and review them on your own time. If you didn't catch something during class, if you just wanted to go back and look at some concepts, if you just wanted to reiterate what you had already learned, or even if you miss a lesson, these are all here for you to use at your own discretion. I will post them on our virtual learning site, and they'll always be there for you to use whenever you would like and access. You don't necessarily have to watch these if you feel like you got everything in class. You can watch these before class because they can often help you better understand stuff as we're going along. That's what they're here for. So without further ado, I'm just going to get started. We're going to be starting off with trigonometry. That's going to be our first unit. We're going to do lesson 1 today, which is Introduction and Prerequisite Skills for Trigonometry. In your workbook, which I have posted to our virtual learning platform, please do pages 1 to 4 for homework and all the questions that are there. They will help you better understand what we're going to be talking about today. So just to get started, our learning goals for today are as follows. By this end of this lesson, you should be able to know how to solve equations with variables in them. You'll know how to use the Pythagorean theorem and how to apply it for triangles with 90-degree angles. You'll know how to reduce fractions and ratios, as well as how to solve for x with fractions and ratios. You'll also know how to find the missing angles of a triangle using the sum and angles triangle theorem. So we're just going to get started. Our first unit, like I mentioned, is trigonometry, which is a study of angles and the side lengths in triangles. Trig is used in geology, surveying, city planning, space travel, building design, and determining inaccessible distances. So we're just going to get started with this first part. We're going to talk about very quickly how to solve equations. When we solve equations, I like to use something called a balance method, which is basically whatever you do to the right side, you got to do to the left side, right? And usually if you're trying to isolate for a variable, you're always going to do the opposite of what was the original thing that's happening to that number. So if we're going to go here, I'm just going to zoom in. We have x squared equals 16. So we know that some number after you square it will give you 16. If I want to determine what x is by itself, I'm going to need to get rid of this squared. That's when I know I have to do the inverse or the opposite of squaring. So I know that the opposite of squaring a number is square rooting a number. So I'm going to square root x to get rid of, so to say that too, the squared and the square root cancel out. Whatever I do to the right side or whatever I do to the left side, I have to do to the right side. I can't just go around square rooting one side and not square rooting the other, right? So I got to square root this side too. So I know if I square root x squared, it'll just give me x. And then I need to do the square root of 16, which is going to give me 4. So I know that x is equal to 4, right? So you can pause the video here and try to go on and try to do the other two by yourself. That's probably the best way to go about this. But if you would like, you can just continue to watch and maybe try number 3 on your own as well. So here we have x squared is equal to 9 plus 16. If you remember BEDMAS, which is you need to do brackets, exponents, division, multiplication, addition, and subtraction, right? You'll know that the first thing you should probably do over here is actually the addition and subtraction, right? Because you want to know what's going on with this 9 plus 16. It's just easier. I like to see each side of the equation as brackets, right? So it's just easier to solve that way. So if I had x squared, I'm just going to do 9 plus 16, which I know is 25, right? And then I'm stuck back where I was before, right? I had an x squared, right? And it was equal to 16. Now I have an x squared and it's equal to 25. So if I want to get rid of that squared, I'm going to just square root this side. I'm going to do the same to this side, right? So I'm left with x squared is equal to 25 square root of 25, right? So x is equal to 5. And I know you must be like missing, this is like grade 9 stuff. But just going over it for people who don't necessarily remember. It's been a while since some of us have done math. Right? So try to do 3 on your own, and then I'll just take it up. So pause the video here. All right. So if we have 8 squared, hopefully you paused and try to solve it by yourself. If we have 8 squared plus b squared equals 12 squared, the first thing you should probably do is just square all the numbers that you need to square and can. So I know that 8 squared is 64. I know that b squared, I don't know what it is. And I know 12 squared is 144. Right? Now, if I want to get this b squared on its own, what I have to do is I'm going to have to get rid of the 64 somehow. What I can do is I can just move the 64 over to the other side by subtracting it on both sides. Right? So I'm left with b squared is equal to 144. This is plus 64, so minus 64 on this side. Right? So then I'm left with b squared is equal to 144 minus 64 is going to give me 80. Right? And if I want to get the square, get rid of that. So it's going to be square root. This will cancel this out. And I'll be left with, b is equal to 80 squared, which is about 8.9. Right? With these, I would just leave it to the first decimal place. All right. So moving forward, we're just going to move on to what I call the Pythagoras theorem. The Pythagoras theorem is basically this equation, a squared plus b squared equals c squared. When you're labeling your triangle, be careful what you label a, b, or c, because the numbers can change and it can change the way that you answer a question, right? You can also write this just the backwards way. You could write c squared equals a squared plus b squared. You might have seen it like that. Another way you could have seen this is that, say you have the hypotenuse, you could do c squared minus a squared equals b squared, right? Or it might be even c squared minus a squared equals b squared. All of these are just rearranged formulas of the same equation, just c squared equals a squared plus b squared. Okay? And an important note here, and I think this is the one people often forget, especially as we move on to cosine and sine law, you can only use this equation with right angle triangles. It doesn't work with regular triangles. You can only use it with triangles that have this right angle right here. It's a 90-degree angle, and that 90-degree angle is always opposite to your C or your hypotenuse. Okay? So, in order to use the Pythagoras theorem, this is just a review from grade 9, you're going to find and label the hypotenuse. The hypotenuse is always the longest side across the right angle, right? It's always that like slanted side. It's the one opposite to, so if you were looking at your right angle, it'd be directly opposite to it, right? And then A and B are the legs of the triangle, so they're the ones that actually make up that right angle. They're always the ones adjacent to it. Okay? So, what you're going to do is you're going to find and label the hypotenuse. You're going to say, okay, this is C, and then you're going to go in and pick one side as A and one side as B. Honestly, you could have picked it as A over here and B over here. It wouldn't have made a difference. The only thing that would be wrong is if you put A here, right? Because C can't be one of the legs. So then you just fill in the values into the equation, and then you solve for the unknown. So we'll go in here and we'll do a couple of questions together. You can try these on your own first, or you can just follow through and watch as I do them as well, because this is a little bit of review from last year. So just going to go in through here and try these by yourselves. So first things first, it says pick and label the hypotenuse. So I know that this is my right angle. So the opposite one is going to be X. So C, right? And then I'm just going to label this A and this B because that just makes sense to me, right? So I'm going to go in and write in what variables I have. So I know that Pythagorean theorem is A squared plus B squared equals C squared, right? So let's go put in our numbers. So we have 6 as A, and always put stuff in brackets because that makes a difference. 5 squared equals C is X squared, and you know what, to be honest, you can write X squared like this. Same diff. Okay, so 6 squared is going to be 36. I know that 5 squared is going to be 25. And I know x squared is what I'm looking for, so I don't know what x squared is, obviously. Right, so then I'm going to take 36 plus 25. If I put that into my calculator, it's going to give me 61 equals x squared. Right, I want to get rid of that square on this side, so I'm going to square root the entire thing. And whatever I do to one side, I have to do to the other. So I'm going to do square root of 61. That means that square root of 61 is like 7.8, right? 7 point, sorry, I'm just going to put it into my calculator. So it's like 7.81024, right? I'm just going to use the first number. I usually like doing to the second decimal place, so I'll do 7.81. But if you leave it to the first decimal place, that's fine too. Equals x. I just like, if you use this number later on in something else, it makes more sense to leave it to 2 or 3 decimal places, just so that when you answer your question, it's more accurate later on. Okay, so that's your answer. You know that side C is going to be 7.81 centimeters. One way to make sure that this is right is that this side C always has to be larger than the two A and B sides. Cool? All right, so I'm going to move on to number 2. Same idea, right? Now, this is my right angle triangle, and this is where it gets kind of complicated. The opposite I already have. I have C. I'm going to say I have A, and I'm going to look for B. Same idea, though. I'm still going to go plug everything in the way I need to. So A squared plus B squared equals C squared, right? So I'm going to say, all right, A squared is 4, B squared, and I'm sorry, sometimes I'm really bad at form. So 4 squared plus Y squared equals 8 squared. Right, gonna go in, fill in, do my squares first. So 4 squared is 16 plus Y squared, I don't know what that is yet. And I know that 8 squared is 64. So then I'm going to do, okay, Y squared is equal to 16 plus Y squared is equal to 64. I don't want that 16. I want that Y squared by itself. So I'm going to move the 16 to the other side. So I'm left with Y squared equals 64. This is positive 16, so it'll be minus 16, right? So Y squared is equal to 64 minus 16 is 48. Want to get rid of that squared, so I'm going to square root both sides, right? And Y is going to give me square root of 48. I'm just going to throw that into my calculator. It's going to be 6.928, so I'm just going to leave it as Y squared is equal to 6.93, and it was millimeters, so always make sure you put in, oops, and this is, because this cancels out, always make sure you put in your units. Cool. So try doing 3 on your own. So pause the video here, try going through it by yourself, and then we'll come back and take it up. All right, so hopefully you paused it, try to do it by yourself. I'm just going to take this one up. So I'm going to go look in here. This is my right angle triangle, so the opposite one is going to be C. And then I'm just going to label my sides here. I'm going to label this as A. I'm going to label this as B. Okay, so I'm going to do A squared plus B squared is equal to C squared, right? So then I'm going to do, okay, Z is A, B is 1.2 squared equals C is 3.1, and these are all meters. If you don't want to put in the units while you're solving, just make sure you put it in at the end. Right, so I have Z squared plus 1.2 squared is going to give me 1.44. 31 squared is going to give me 3.1 squared is going to give me 9.61. Right, and then I'm left with Z squared is equal to, I want to move the 1.44 to the other side. So 61 minus 1.44 because it's a positive. Right, and so I'm left with Z squared, I'm just going to do this. Z squared is equal to 9.6.1, 9.61 minus 1.44 is going to give me 8.17, right? And then I want to get rid of that squared, so I'm going to square root it. Square root. And then I'm left with z is equal to 8.71 square root, which is going to give me, I'm just going to put into my calculator, 2.858. So I'm going to do 2.86, and it's meters, so I'm going to go put in meters. And that's my answer. Alrighty. Again, if you have any questions, just feel free to ask. You can always send me an email. Proportions and ratios. So I'm going to go over and we're going to quickly just review how to solve for x in fractions. Fraction seems to be the one thing that a lot of students find trouble with. So we can do this one of two ways. I'll show you how to do them both ways. In my personal opinion, I like to get rid of the denominator first, but it's completely up to you how you decide to do it. I do not have I will follow your mistakes through either way. Okay, so just going to go here. I'm just going to quickly pause this first. Alrighty, so just going to start off with this first one, and this is the one that I'll show you both ways how you can do this. One way you can get rid of the denominator, the other way you can just solve for x by isolating x. So let's start off the first way. So one way that we could go about doing this is getting rid of the 8 here, right? So if I want to isolate, I can say x divided by 8. And if I want to get rid of the 8, I just need to do the opposite of division, which we know is multiplication. So I'm going to multiply this side by 8, right? And then I know that on this side, whatever I do to one side, I have to do to the other. So both sides is multiplied by 8. And I know that'll give me, so this will just cancel, right? So I'll be left with x. So I'm going to go back and do it in double it. X is equal to 1/2 times 8, which is just 4, right? So I know that x is equal to 4. So that's one way of doing this. You could also have done it in the sense that, in case you don't know where that 4 came from, right? 1 times 8 is 8. 2 times, and this is just over 1. 2 times 1 is 2, right? 8 divided by 2, x is equal to 4. You don't necessarily always have to show these steps. I'm just showing you how to do them. Okay, and then I'm just going to go in here and zoom in a little bit so that I have a little bit more space, but I'll do it the other way as well. So another way that you could do this is you could have seen, okay, x divided by 8 is equal to 1/2, right? And then what you could have gone in and done was been like, okay, let's cross multiply. So I don't know if your teachers have taught you how to cross multiply, but you basically just do this, right? So you do 2 times x, and it only works if there's an equal sign in between them two. And then 8 times 1, right, is 8, and then you just divide both sides by 2 over here. X is equal to 4. Personally, I prefer cross multiplication. For me, it makes sense. When we move on to solving SOHCAHTOA, this will be easier than trying to find the common denominator and doing all of that stuff. If you don't understand how to do that, that's completely fine. I will show you how to cross multiply, and that's how I'm going to solve the next few equations. But or how I'm going to solve equation 3. I'll use the x method to do the other one. But it's completely up to you how you want to go ahead and solve this. But cross multiplication, I find often is a little bit easier. Okay? All right. So if we have 15 equals 30 over x, and I'm trying to solve for x, I know that x is in the denominator here, so I can't really do much with it. So I'm going to have to get rid of it somehow. So I'm going to multiply both sides by x. Right? So 15 times x is going to give me 15x. In this situation, the x's will cross out, right? And then I'm just going to divide both sides by 15 to get rid of that 15 in front of the x. And x is going to be 30 over 15, which is 2. Again, cross multiplication will work here too, and I'll do that. If I had 15 over 1 equals, and I'll do it in a different color. So let's do this in blue. So if I had 15 equals 30 over x, right? And I pretended that this was 15 over 1 because any whole number is just over 1, right? I can cross multiply. I can say, okay, I have 30 and 1. Multiply those together. 30 times 1 is just 30. 15 and x. Also, 15 times x is just 15x, right? Same idea. Divide both sides by 15 because I want to get rid of the 15 in front of the x. And I'm left with 2 equals x. Either way is correct. Doesn't matter which way you do it. Okay? So this is a over 20 equals b over 4 equals 6 over 12. A little bit more complicated because now I have like 3 equal signs, which is like, what? So what you can do here is, since all 3 of these numbers are equal to each other, we can just use a over 20 and 6 over 12, and we can equate those to each other. The other thing I can do is I can do b over 4 and make it equal to 6 over 12 as well. 6 over 12 in this situation is the only one that I know a number for. Like, I know both numbers, so I have to use that. I'm looking for a. I don't know what b is, so making a over 20 equal b over 4 is effectively useless for me because I can't solve anything. I'm just going to be left with 2 variables. So what we're going to do here is we're going to break this up, right, even further, and I'm going to say, okay, a over 20 is equal to 6 over 12, right? I'm going to use cross multiplication. Again, I personally prefer that way, but whatever way you decide to do it is fine too. So I'm going to say, okay, a times 12 is going to give me 12a. And then I'm going to do 6 times 20, which is going to give me 120, right? So it's going to give me 120. And then I want to get rid of the 12 because I want the a by itself. So a is equal to 120 divided by 12, which is going to give me just 10. So a is equal to 10, right? Going to try doing the same thing with the b now. So I'm going to do that in this green color. So I'm going to say, okay, b over 4 is equal to also 6 over 12, right? So I'm going to do the same thing. I'm going to cross multiply. I'm going to do b times 12, 4 times 6. And I just use this dot to represent multiplies because I don't like using x's. So 12b is equal to 4 times 6, which is 24, divided by 12 to get the b by itself. B is equal to 24 over 12 is 2. So I know b is equal to 2, right? And that gives me my 2 answers. I solved for a and b. I solved the question, and I'm going to move on. The last kind of review thing we're going to do is we're going to talk about angle summa of a triangle, right? So I don't remember if any of you remember this from grade 9, but the angles inside of a triangle will always add up to 180 degrees. So everything inside of all the angles, 1, 2, 3, there's 3 angles inside a triangle, they're always going to add up to 180 degrees. This theorem can help us determine angles if we already know 2 angles in a triangle. And usually when I give you a right angle triangle, you will know 2 angles already, right? So let's try to solve the first one. I have this triangle, I have this angle right here, which I know is 90, right? Because it's a right angle triangle. I have 48, and I'm trying to find out what is this angle right here, right? So I'm going to label this angle x. So I'm going to say, okay, so I have, I know that everything that I do, I know that if I add up angle A plus angle B plus angle C, they're all going to give me 180 degrees, right? So let's just go in and say, all right. And for our purposes, angles are always going to be uppercase letters, right? So I know angle A is 90 degrees. Right, I know angle B is x, I don't know what it is. And I know angle C is 48 degrees. And that's all going to equal 180. So let's just collect our like terms here. We know that we can add these two together to make our life a little bit easier. So let's do 90 plus 48, which is going to be 138. 138 plus x is equal to 180, right? And now I want to get rid of that 138, so I'm just going to move it to the other side by subtracting it on both sides, right? So I'm left with x is equal to 180 minus 138, which is going to give me 42. So I know x is equal to 42. Another thing you could have done is you could have honestly been like, I don't want to do any of this stuff. I'm just going to do 180 minus 48 minus 90. Also, right? Would also give you 42 degrees. Okay, just make sure you put your degrees in. Here, you're like, Miss Singh, you said you'd always give us two angles. What? I didn't give you two angles, but one thing you need to know is that if all the sides of an angle are equal, all the angles are also equal. So I know that angle, let's just label this as A, B, C again. So I know angle A plus B plus C is all going to give me 180, right? I also know that angle A is the same as angle B is the same as angle C. So I can just say 3A is equal to 180. So I can just divide both sides by 3. And I know that each of my angles is going to be 60 degrees because A is equal to B is equal to C. Cool. Hopefully that makes sense. All right, and that is the end of your lesson for today. So if you could please go back, your homework questions are right here. They're the workbook pages that I have put onto our virtual learning environment. The trigonometry workbook is going to be like your textbook for this course. So just go in and do pages 1 to 4. And that is all for homework. Thank you. Have a great day.